This lesson is on direct variation. Already in this course, you've looked at direct linear variation. However, in today's lesson, we're not just looking at direct linear variation, we're looking at direct variation. So direct variation occurs when both variables change in the same direction. In other words, as one quantity increases, the other increases. Now, the type of variation that we've looked at when we looked at linear functions topic was y varies as x, and we wrote the equation y equals kx. Well, today, when you've got direct variation, it doesn't just have to be linear. You can have, for example, y varies as the square of x. So instead of writing y equals kx, we would write y equals kx squared because the square of x is x squared. You could also have y varies as the cube of x. In other words, instead of writing y equals kx, we write y equals kx cubed. Direct variation, as one quantity increases, the other increases, okay? So linear variation, y equals kx, y varies as x, y equals kx. Y varies as the square of x, y equals kx squared. That's always our first step. Y varies as the cube of x, y equals kx cubed. And then we do the same steps as what we did before for the direct linear variation. We substitute values of x and y to work out k, rewrite the equation, and then do further substitution later. So we have done questions like the first line. The only difference today, we're doing squared and cubed as well. So some examples here, we've just got some examples here of direct variation. Okay, so the bigger the car, the more fuel you use. The heavier, if you've got a mass on the end of a spring, the heavier the mass, the longer the spring will stretch. And yeah, this viewing range and height of tower. The further you go up a building or a tower, the further you can see. Okay, so again, the 4 steps are exactly the same as what we did before. Okay, so we'll write our equation out. We'll substitute the x and y to find k. We rewrite the equation with k in it, and then we answer the question by substituting a value. Okay, so if you see y is directly proportional to x, that is exactly the same as saying y varies directly as x. Now, because we've already done the cubic equations, the squared equations, we've got 3 equations here, y equals kx squared, y equals kx, y equals kx cubed. I want you to tell me this first one here, this is a straight line graph. Which one do you think, this is a straight line graph. Which of these above do you think it would be? Y equals kx squared, y equals kx, y equals kx cubed. Which one? Come on. Kx, that's like y equals mx plus b. So that would be y equals kx. That's a straight line graph. Now, we've got a parabola or a cubic. Which one do you think would be steeper? I know we haven't directly looked at these, but let's say you do when x is 2 for each one. Let's say we looked at something like y equals x squared, y equals x cubed. I'm not saying that that's in that order. But when x is 2, what do you get for the y equals x squared graph? And for example, when x is 2, what do you get for the x cubed graph? Let's say, I'm trying to work out which one is which. Yes, it is half a parabola, but they both look the same. Which one is steeper? That's what I'm asking. Which one's which? Well, let's just do a substitution. Let's say you have the curve y equals x squared and y equals x cubed. When x is 2 for the graph y equals x squared, what does y equal? If you substitute x is 2. And for this one, when x is 2, what do you get for y? No, you get 8. 2 cubed is 8. So in other words, you might have the point 24 on one graph and on the other curve. So you might have the point 28 on this, and on this one, the point 24. So let's say you've got 2, I don't know, 4 and 2, 8. Do you sort of get what I'm doing here? Yes. The cubic one is the steeper one. The x cubed one will be steeper. This is the y equals kx cubed type graph. So the x cubed graph is steeper. And that would be the y equals kx squared type graph. I know you can't see the values there on the graph, but an x cubed graph is steeper than an x squared graph. For example, by substituting in just the same value of x, you can see you get a bigger value of y for a cubic. Now, that cubic graph, we know from what we've done so far that a cubic looks like this. That is the y equals x cubed graph. And y equals x squared looks like this, right? But because you could only see quadrant 1, you couldn't tell which one it was. They both look the same here, but the x squared graph will be steeper, okay? Like if it's 1x squared. Would be steeper. So this is multiple choice, girls. They're not actually the graphs. I should have left a bit of room. The x cubed graph will be steeper than the x squared type of graph, okay? So if I was to label which graph was which, that straight line, x cubed would be steeper because when you put a value of x, you get a bigger number, the same value here and there. All right. Now I need to move on. That's a y equals x squared type of graph, not a steep. But if you're only looking at quadrant 1, they're going to look the same. All right. Oh, question 5 from your textbook. So the distance d that can be travelled by Grace's car varies directly as the volume v of petrol in her car, and she travels 465 kilometres on 45 litres of petrol. So d varies directly as the volume. So what do I write? I write d equals k times v. Okay? Now, what do I do next? I have information. You can travel 465 kilometres on 48 litres of petrol. So we substitute d is 465 kilometres and volume is 48 litres. Now, we've already done this before, okay? So 465 equals k times 48. So 465 divided by 48 is k. Anyone worked out what k is? It's a bit under 10. I don't know, or you might get a fraction.
9.68.
Can I have an answer as a fraction, please? I don't want a decimal. If that simplifies, that's fine. If it doesn't simplify, it should stay as it is. Otherwise, you're going to end up with rounding errors later. What have we got?
But it's only 4 decimal points, 0.6875.
So that actually, could you just press change and tell me what it is a fraction?
9/11/16.
Yeah, write it as an improper if we were to do that. Can I have that as an improper fraction?
9 and 11.
No, improper. 155 over 16 is as an improper fraction. You put equation, you could write it a couple of ways. D equals, if we've got the simplified fraction, that's fine. 155 over 16v, or you could write it as 9.6875v, and I recommend only doing it that second way if it's a terminating decimal, and it is. And that's fine. You just don't want rounding here. So if it's not a terminating decimal, write it in the fraction form. If it is a terminating decimal, it's fine to write it as the decimal. We really don't want to be doing rounding here, because we could end up with errors later. So that is our variation equation. We've got two possibilities. They are the same thing. Now, and it still would be fine to write D equals, you could even write D equals 465 over 48 V. That's fine as well. Okay, it doesn't have to be simplified. Okay, that's question A. Question B, it says, how far to the nearest kilometre can Grace's car travel on 56 litres of petrol? 56 litres is volume, so the volume is 56 litres. You're just working out the distance. It's 9.6875 V, which is 9.6875 times 56. Anyone got an answer?
542.
542 point, exactly. 5 kilometres. Make sure your units are correct. So we've already done this sort of thing in linear variation, all right? And the last one, how many litres of petrol does she use to travel 200k? 200k is a distance, and you're finding the volume. So writing your formula out, D equals 9.6875 V. We know the D, distance, is 200, and you're just solving for V. Okay? Just answer, yep, 645. which is to 1 decimal place 20.6 litres. Now, like I said, we've done this before. We've done direct linear variation, but we're now going to do direct non-linear variation, but it's still direct. Okay? Here, the braking distance B meters of a car is proportional to the square of its speed S. So this time, instead B equals K, instead of writing KS, it's just K times S squared. That's the only difference. The only difference. Now every other step is the same. The square of its speed, not the square root, the square. B is proportional or varies directly with, remember, proportional means varies directly with the square of its speed. So B equals KS squared or K times S squared, same thing. Can you see the difference? Instead of just B equals KS, it's B equals KS squared square of the speed. Every other step is now the same. We have to work out K by substituting. We put the K value back in, and then we substitute again to answer our question. So find B in terms of S. We need the constant of variation as a fraction. So what do we substitute? 80 kilometers per hour is a what? So when S is 80 kilometers per hour, what's the other one? B is 90 meters. That's your braking distance. So we've got 90 equals K times 80 squared. 90 equals K times 6,400. So 90 over 6,400 equals K. Well, look, we know we can divide numerator and denominator by 10. So it's 9 over 640. Now, I don't think that can be simplified, because the only thing that you can divide 9 by is 3, and 640 is not divisible by 3, because 6 plus 4 is 10, 0 equal 10. And remember that rule in year 7?
No.
A number is divisible by 3 if the sum of its digits is divisible by 3. You can't divide 640 by 3 or 9. So K is 9 over 640. So therefore our formula is B equals 9 over 640 times S squared, or you could write it as, be careful here, B equals 9S squared over 640. Are we okay with that? Because it's 9 times S squared. S squared is on the numerator over, and 640 is on the denominator, because S squared is S squared on 1. You don't have to. Yes, you can leave it like that.
That's the formula. No.
What is the braking distance to the nearest? Girls, you need to understand that, because S squared is S squared on 1. So that's 9 times S squared over 640 times 1 is 640. Okay, now for B, what is the braking distance to the nearest meter of a car traveling 70 kilometers per hour? So B equals question mark. Speed is 70 kilometers per hour. So we're just going to substitute that into our equation. So it's 9 over 640, if you like, times 70 squared. Okay? Which is, I'm just going to do it over here on the same line. So remember the formula is B is 9 over 640 times S squared. We're just substituting S is 70. What do we get?
68.
68.
0.906.
0.9, let's just do 0.9, 906. They're asking to the nearest meter, which is 69 meters. Now let's just see that this makes sense. When you're traveling at a faster speed, braking distance should be longer. So traveling at 80 kilometers an hour, braking distance 90 meters. Traveling at 70 kilometers an hour, if you're going slowly, the distance that you take to brake should be shorter, is 69 meters. So that does look correct. Okay. Now for part C, and what speed to the nearest kilometer per hour is a car traveling if it takes 120 meters to stop? Well, your 120 meters to stop is your braking distance, and they're asking for the speed is question mark. Using your formula, 120 equals 9 over 640 times S squared. Now, this is why I wanted to write the formula like that earlier. Tell me how you're going to... There are two ways you can do this, because it's s squared times 9 over 640. If 9 over 640 was a whole number, wouldn't you do 120 divided by whatever that number is? That's your other way to do it. Because it's s squared times that, you could just do s squared... What's the inverse operation of multiplying? It's dividing. Are you okay with that? What was if this was 120 equals 5 times s squared? Wouldn't you divide by 5? If this number here was 5, for example, you do 120 divide by 5. True?
True.
You can just divide it by the value that it is, which is 9 over 640. That's one way of doing it. The other way you could do it is... Someone else tell me the other way you could do it. You'd multiply by 640. Yeah. And then you'd get 9s squared. That's the other way. And then you'd, whatever you get there, you'd then divide it by 9. Okay? But if you treat that as just one number, do you get what I'm doing here? If you treat this as just one number, because you guys are the ones that want to write it this way, it can actually benefit you by doing that if you say that's just a number and you divide by that number. Do you get it? So what do we get here? Anyone? So it's 120 times 640 over 9.
8,533
And 130.
0.3 recurring, but that's s squared. That's the speed, girls. No cars traveling at 8,000 kilometers an hour. So square root it. And I'm running out of room. Just don't round yet. Which is?
92.3760.
So we want it to the nearest kilometer per hour. So 92 point.
92.3.
So I'm just going 92 kilometers an hour. Okay, so that one was the same. I'm not going to, that's just an alternative way to do it, etc. Okay? But if you want to write this as a fraction, like I said, it can really help you by just treating it as a single number. If it was, just do the same thing you would do as if it was a whole number. All right? By treating 9 over 640 as a single number, or you can go inverse operation of divide by 640 is times 640. And then you've got 9s squared, then you've got to divide by 9. All right? So at the very beginning of the exercise, we had 3 graphs here, a straight line graph, a cubic, and and that's only part of the cubic. Remember, a cubic looks like this, but we're only seeing the first quadrant, that first quarter there. So let's say you might get a question like this. If I was actually to draw that, that's just D equals 9.68V. It's just a straight line. It's like Y equals 9.68X. So that would look like this, that type of equation. That's a straight line graph. Sorry. Okay, do you get that? It's almost like D equals 10V. Straight line graph, very big gradient of 10 roughly. That's what that would look like. I'm not going to put any values in. This one, that the distance is proportional to the square of its speed, that type of graph would look like a quadratic graph. So B is proportional to the square of its speed. So, well, the other bit would look like this, but it's not relevant because you don't have negative speeds, right? That graph would look like this. Yeah. So that would be like because the graph is B equals 9 over 640 times S squared, actually, it would be quite wide, but it is like a Y equals something X squared type graph. It would look like a parabola. Now, remember, you can't see the other side of the parabola. All right, it's only half of it. This type of question, question 11, the cost, yes. Now, a cubic normally looks like this, but you are not going to see, you will not see this section of the graph. Do you understand? Oh, sorry. So this other one is a cubic, which has that shape, but you won't see this section here. Do you understand? You'll only see this section. Now, a cubic and a squared graph look the same. The only way you could tell them apart is by substituting values. And a cubic is just a lot steeper. Okay? It's about the cost of a car varies. It varies means varies directly with the cube of its speed s. So what do I write? Cost equals k times s cubed. Okay? So girls, very similar to what we were doing before. If this question had a graph associated with it, it would look like that, but you would not see this portion of the graph. You would only see the c and the s. It's not c and s cubed. It's the c axis and the s axis, but that is the graph c equals something s cubed. I'm about to work out what that something is. Yes. This is the variation c in terms of s and k, but the problem is I haven't got any information yet. So that's our first equation. Part B, if it costs $1.25 per kilometre, C is the cost per kilometre. So when C is $1.25, it costs $1.25 per kilometre to run the car when it's travelling at a speed of 60 kilometres per hour. You have to find K. So we write out our equation and we substitute C is 1.25 and S is 60. Just making sure that what you're substituting is in the same units. Now it is C dollars per kilometre and that is $1.25, so the units are okay. So therefore K is 1.25 divided by 60. Girls, they want it in scientific notation, correct to 4 significant figures. So 1.265 divided by 60.
Miss, isn't it cube?
Cubed. Thank you. Thanks. What do you get? That's 60 cubed. It's
5.787 times 10 to the negative.
5.787. I need more. Yeah. Can I have it all? 5.786 something or 7 something?
It's 787. Oh no, to that it's like 0. 036.
Give you the answer in scientific notation straight away. Others, like this. You're going to have to count. So from where the decimal point is, we jump forward 1, 2, 3, 4, 5, 6. So that is, because it is a small number, it's 10 to the negative 6. It's 5.787 times 10 to the negative 6. Oops, sorry. Girls, this is a very small number, yes? Scientific notation has to be written as a number between 1 and 10 times 10 to the power of something. So I move my decimal point till I get a number between 1 and 10. So I jump 1, 2, 3, 4, 5, 6. I stop at between the 5 and the 7, which is 5.787. Now that is a number between 1 and 10. So 5.787, I jump 6 places. And that's obviously a very small number, so it's 10 to the negative 6. All right? So now to 4 significant figures means I'm allowed 4 numbers here. 5.787, and I know it's times 10 to the negative 6. Now, on your calculator, for scientific notation, but you've got it this way. So on these calculators, the Sharp EL531, you just press set up. You're listening? Set up. FSC is 0. SCI is scientific notation. And it gives you the answer in scientific notation, which is 5.787, whatever, times 10 to the negative 6 for C. All right, so that is K to 4 significant figures. So the formula is C equals 5.787 times 10 to the negative 6 times S cubed. I know that looks a bit weird, so I'm just going to put it in brackets. Now, the last question for part C says, hence, calculate the cost of running the car when it is traveling at a speed of 85 kilometers an hour. So C equals 5.787 times 10 to the negative 6 times, speed is 85 kilometers an hour, so times 85 cubed. Okay? Now, do we know how to put that into our calcs? You might just keep it in there. Anyone? So it's going to be $1 something. Remember, the cost is dollars per kilometre. Anyone? You enter that on your calculator because we know that C equals 5.787 times 10 to the power of negative 6 times S cubed. When you enter this on your calculator, you're getting 3.55. Remember, C, the units are dollars. So it's $3.55 per kilometre. Okay? This answer here, you press cancel on your calculator. I mean, you can just go back in and do it again and it'll stay there. But if you want to do 5.787 times 10 to the power of negative 6, you can go times 10 to the power of negative 6, or the EXP button. As soon as I press EXP, it automatically brings up times 10 to the power of. Can you see it? See, if I press, so what I'm doing, 5.787, if I press EXP, it already does three things for me. It's got times 10 to the power of something, and I just press my little plus or minus button, minus 6, and it comes up like that. Sorry, it's a bit glary. 5.787 times 10 to the power of negative 6. That's one way of doing it, and then going times 85 cubed, and you get 3.55. The other way of doing it is to go as follows. 5.787 times 10 to the power, that's this button, to the power, this button. And then you've got to go back down here, negative 6. Now that's another way of putting it in, but the EXP button does it for you in one step. And then times 85 cubed. All right, so two ways. If you cancel 5.787 times 10 to the negative 6 on your calculator, you go 5.787. You press your EXP button. When you press that, times 10 to the power comes up for you. Then you press your little negative button, not minus, negative button, 6. That's how you enter it. Or you could go like this, 5.787. You press times. You press your Y to the X button or your X to the Y button, and you press, sorry, no you don't. You go times 10, then you press the Y to the X button if you want, and then press negative 6. Negative 6, not minus 6, negative 6. So that's two ways of entering 5.787 times 10 to the negative 6. That's two ways of entering that, if you want to enter that. Some of the newer calculators actually have the times 10 to the power of X button already.
It's called what? Log.
Because it doesn't have the times 10 to the X directly, but the on top of the log button is the 10 to the X. Does it have a times in front?
No.
Right, so you would press 5.787 shift or second function. Do you get it? That log button, and then you press negative 6. So that's three ways. So I don't know if any calculators, some might have the 10 to the X button as well. All right, so there's many ways of entering it. This is the last type. The height of a particular termite mound is directly proportional to the square root of the number of termites. Girls, it's not square, it's square root. So height equals K what? What do I write? Times square root, I'll put T for number of termites. Okay, so height, anyone that's done this one, you need to go back and check. The height of a particular termite mound, so H for height, is directly proportional to the square root. It's still direct proportional, square root of the number of termites, T. So H equals K times square root of T. You know what we're going to do? Let's go to the front. Girls, go to the front of your booklet. Y, this is another type, varies as the square root of X. Excuse me, ladies, go back to the front of your booklet. Let's add one more type. Y varies as the square root of X. The equation is Y equals K times the square root of X. Are we okay with that? Y varies as the square root of X is another type. It is direct. Of this mound, now notice in all the other questions you've had guidance. This one, there's no guidance in this question. The height of this mound is 35 centimeters when the number of termites is 2,000. So H equals 35 centimeters when termites is 2,000. By knowing those details, what can I find?
The K.
I can find the K. So I go H equals K times square root of T. I put those numbers in. 35 equals K times the square root of 2,000. So K equals 35 over the square root of 2,000. You might want to keep it like that, or I would probably keep it like that because it's just a multiple choice question. They're only going to ask us one more little thing, and hopefully it's not going to be backwards. So I'm going to leave it like that. So therefore my equation is H equals 35 over the square root of 2,000 times T, times the square root of T. That's my formula. Unless you want to put a value for it. Anyone got a nice value? 35 over the square root of 2,000. 0.7826, etc. Now what I would do, just keep it there. Don't cancel it off your calculator. Just leave it if you've done it. Now let's answer the question. What is the height of this mound in centimeters when there are 10,000 termites? So when T is 10,000, H is, that answer there, just don't cancel it off your calculator, times the square root of 10,000. So all you've got to do now is go times square root of 10,000. Girls, this process is exactly the same as what we've been doing. You write the formula out. You substitute two known values to work out K. You put the K back into the original equation. You can write it as a decimal if you want, but if you do not press the cancel button. So you write your equation out, and then you answer the question. When T is 10,000, work out what H is. What do we get, girls? Anyone?
78.2.
78.26, whatever, which is, yes, which is approximately 78, which is answer B in the multiple choice. That is a multiple choice question. Write the first step. Do you think you know what to do after that? E varies directly with the square of S. What do we write? E equals K, no, times S squared. E varies directly with the, no, the K is never squared. The square of S, not the square root, the square of S. All right? Now what do? We substitute. Sub E is 20, S is 10. What do you get? 20 equals K times 10 squared. 20 over 10 squared equals K. I think you get the K is what? 0.2. 20 over 100.
Yes.
1/5 or 0.2? Let's leave it as a decimal. This one's not hard. So now, what is the value of E when S is 40? So my formula is E equals K, we know is 0.2 times S squared. That's our formula. So now, what is E when S is 40? We sub S is 40. E is 0.2 times 40 squared.
320.
Is that what we get?
Yep.
320, which is C. And there's one more question. The mass of an egg, let's go M, is proportional to the cube of its length. So, M equals K times L cubed. That's it. It's the worst bit of it. Write the equation out. If an egg of length 6 centimeters has a mass of 54, when L is 6 centimeters, mass is 54 grams. 54 equals K times 6 cubed. Are we good? So girls, the first line is crucial. Mass is proportional to the cube of its length. M equals K times L cubed. The length is cubed, not the K. So we've got 54, 6 cubed divided by 6 cubed equals K, or you could work out that 6 cubed is 216 and do 54 over 216. What do we get? It's 0.25. Yep, it's a nice decimal that terminates, or you could leave it as a quarter, but decimal's nice and easy. So M equals 0.25 times L cubed is your equation. Notice we're just doing the same thing over and over. The only difference is the first step. And now we answer the question. What is the mass? So find M if the length is 8 centimeters. That's the question. What is the mass of an egg with a length of 8 centimeters? M is 0.25 times 8 cubed.
Yay.
128 grams, which is D. Okay, that is direct variation.